Statistical Hypothesis Testing. This topic is a part of Biostatistics and Research Methodology in Pharmaceutical Science. The content of this topic includes concept of hypothesis testing, types of hypothesis, null hypothesis and alternative hypothesis, types of errors, type 1 error, and type 2 error, p-value, sample size, steps involved in the hypothesis testing, and applications of hypothesis testing. Hypothesis testing, synonym is significance testing. Definition: hypothesis testing is the process of inferring from a sample whether or not to accept a certain statement about the population from which the sample was taken. Hypothesis testing is a powerful statistical technique for confirming whether something is as you believe it is. It can be used to assist the experimental in comparing the two datasets. Also allows the comparison of the two formulations to be made on objective terms with knowledge of the risks associated with reaching the wrong conclusion. This is the technique that leads to the familiar statement, the difference is statistically significant, or significant difference, at the 5% level or less. Statistical hypothesis. Definition: statistical hypothesis is some assumption or statement which may or may not be true about a population or equivalently about the population probability distribution, which we want to test on the basis of the evidence from a random sample. The hypothesis reflects some assumptions about the problem situation. For example, new drug is more effective than a marketed drug. New formulation of drug has enhanced bioavailability than a marketed formulation. New antihypertensive drug shows more blood pressure reduction than placebo. The testing procedure is based on the concept of a null hypothesis, that is a statement about a parameter, such as the mean, that will subsequently be compared to the sample estimate of the parameter to test for treatment differences. Key hypothesis types. In hypothesis testing, there are two opposing hypotheses about a population: null hypothesis and alternative hypothesis. Before deep discussion, let's have a look. This poem, often titled, I Am the Null Hypothesis, which was written and designed by Chris Lysy. I am what is, the default, the status quo. I am already accepted, can only be rejected. The burden of proof is on the alternative. I am the null hypothesis. Null hypothesis, symbol is H0. Neutral, or null, means no difference. Null hypothesis is the hypothesis that is tested for possible rejection under the assumption that it is true. The null hypothesis is the statement that there is no difference between the sample statistic and the population parameter. The null hypothesis is an uninteresting hypothesis that we would like to reject. Eve, we find a difference while conducting hypothesis testing The null hypothesis is rejected. Statement of the null hypothesis. H0 is mu1 is equal to mu2, or delta is equal to mu1 minus mu2 is equal to 0. This indicates there is no difference between means of comparison. Example: a clinical study is planned to compare the efficacy of a new antihypertensive agent to the placebo. Null hypothesis is H0 is mu1 is equal to mu2, where mu1 is average reduction in blood pressure due to drug, and mu2 is average reduction in blood due to placebo. Wording statement is there is no difference in average reduction in blood pressure between drug and placebo. Alternative hypothesis. Symbol is H1 or H8. Any hypothesis that is complementary to the null hypothesis is called an alternative hypothesis. Alternative hypothesis is generally the interesting hypothesis that we would like to prove. However, we do not actually prove the alternative hypothesis. We merely reject or accept the null hypothesis. The alternative hypothesis statement stands true if the null hypothesis is rejected. Statement: as null hypothesis is H0 is mu1 is equal to mu2. Alternative hypothesis for above null hypothesis will be H1 is mu1 is not equal to mu2, that is, two-tailed alternative hypothesis, or H1 is mu1 is greater than mu2, that is, right-tailed alternative hypothesis, or H1 is mu1 is less than mu2, that is, left-tailed alternative hypothesis. These right and left-tailed alternative hypotheses are generated in one-sided test. Same example of a clinical study is planned to compare the efficacy of a new antihypertensive agent to the placebo. Alternative hypothesis is H1 is mu1 is not equal to mu2. Wording statement is there is significant difference in average reduction in blood pressure between drug and placebo. Accepting the null hypothesis means fails to reject the null hypothesis, signifies a lack of sufficient evidence to prove the alternative or research hypothesis. It doesn't necessarily mean the experiment failed, but rather that there wasn't enough statistical evidence to conclude a significant effect. Rejecting the null hypothesis signifies a statistically significant difference. Evidence supports the alternative hypothesis that an effect or difference exists. So it is not failure of experiment, but typically signifies a successful experiment. There was statistical evidence to conclude a significant effect. Types of error. First one is type 1 error. This error is also called as alpha error or producer's risk. It is an error when null hypothesis is rejected while actually the null hypothesis is true. That means rejecting a true null hypothesis. The probability of committing the type 1 error is called the level of significance. Finding probability of error is size of type 1 error. So, the probability of reject null hypothesis when it is true is equal to probability of type 1 error is equal to alpha is equal to probability of rejecting a good lot. Alpha is equal to the probability of reject null hypothesis when it is true. Now, the probability of reject null hypothesis when it is true plus the probability of reject null hypothesis when it is wrong is equal to total probability, that is, 1. The probability of reject null hypothesis when it is wrong is equal to 1 minus the probability of reject null hypothesis when it is true. So, the probability of reject null hypothesis when it is wrong is equal to 1 minus alpha. 1 minus alpha is called as confidence coefficient, while alpha level is called as level of significance. Commonly used level of significance is alpha level of 0.05 means 5%, and alpha level of 0.01 means 1%. Alpha level is always fixed during statistical calculations. Type 2 error. Synonyms as beta error or consumer's risk. It is an error when null hypothesis is accepted, while actually the null hypothesis is false. That is, accepting a wrong null hypothesis. Finding probability of error is size of type 2 error. The probability of accept null hypothesis when it is wrong is equal to probability of type 2 error. That is equal to beta. That is equal to probability of accepting a bad lot. Eta is equal to the probability of accept null hypothesis when it is wrong. Now, probability of accept null hypothesis when it is wrong plus probability of accept null hypothesis when it is true is equal to total probability, that is, 1. Probability of accept null hypothesis when it is true is equal to 1 minus probability of accept null hypothesis when it is wrong, that is, 1 minus beta, and also called as power. Power of the test. The probability of rejecting a false null hypothesis is called power of the test. P-value in hypothesis testing. A p-value is a statistical metric used to assess a hypothesis by comparing it with observed data. It is calculated after the experiment, indicating the strength of evidence against the null hypothesis. A way to report the results that the null hypothesis is rejected or not rejected at a specified alpha value or level of significance. This is often called fixed significance level testing. If p is less or equal to alpha, reject the null hypothesis. That is, the result is statistically significant. If p is greater than alpha, fail to reject the null hypothesis, that is, the result is not significant. So, calculated p-value as the smallest level alpha means critical p-value at which the data are statistically significant. Sample size. Sample size may be dictated by official specifications, regulations, cost constraints, and/or the availability of sampling units, such as patients' manufactured items or animals. Considerations. For estimating sample size, the alpha level must be specified, generally set at the traditional value of 5%. The beta error must be specified, is often chosen to be between 5% and 20%, so power of test, 1 beta, is between 95% to 80%. The difference to be detected should be specified. That difference is considered to have practical significance. A knowledge of the standard deviation for the significance test is necessary. Equation to identify the sample size is given below. This equation includes all the parameters we have seen in considerations for estimating sample size. Steps involved in hypothesis testing. The steps for designing and analyzing the experiment are as follows. Careful planning and appropriate experimental design. Generation of null hypothesis and alternative hypothesis. Depending on condition, one can design hypothesis, either two-sided hypothesis testing, that is, bidirectional, or one-sided hypothesis testing, that is unidirectional. The level of significance is specified. The level of significance represents type 1 error, that is, the chance of making a mistake when deciding to reject the null hypothesis. The level of significance is specified depending on the possible risk. In the majority of cases, it is 5% level, expressed as p is less than 0.05. Let us understand level of significance and rejection or acceptance of null hypothesis by probability distribution curve. Area under the curve is the total probability, that is 1. Hypothesis can be one-sided or two-sided. Here we take example of two-sided hypothesis testing with significance level of 0.05. That is, the difference is significant at the 5% level. As it is two-sided test, the significance level is divided in two sides, and significance level divides at the both tails of the curve. Thus, on both sides, significance level is 0.025. The remaining probability distribution is, at the middle area is 0.95. Areas of both tails of the curve show significance level. Significance level is also recognized as critical region or critical level. The point from which the significance level starts on both sides is called as critical point or critical values. Under the null hypothesis and the assumption of normality, X bar is normal with mean mu0, and standard error of mean. If the value of x bar falls in the critical region, the null hypothesis is rejected, and the difference is set to be significant at the 5% alpha level. The sample size. The sample size can be calculated after alpha and beta is specified. Statistical test calculations. After the experiment is completed, statistical calculations are computed. Mean values are to be compared. Examples of tests are z-test and p-test. Z-test is performed when the population variance is known, and if variance is unknown, one sample to test is performed. If the calculated value is more than tabulated value, then reject null hypothesis. Applications of hypothesis testing. Hypothesis testing is used across many fields, such as medicine, business, science education, and finance, to make data-driven decisions. Validating if observed effects in samples are real or due to chance by testing assumptions about populations, like a new drug's effectiveness, a marketing campaign's impact on sales, or environmental changes. Applications of hypothesis testing are better explained in exercises of p-test and ANOVA. End of the topic of statistical hypothesis testing. You can refer to these mentioned books for this topic. Fundamentals of Statistics by S.E. Gupta. Pharmaceutical Statistics, Practical and Clinical Applications by Sanford Bolton. Basic Statistics and Pharmaceutical Statistical Applications by James DeMuth. Multiple choice question asked in competitive examination. A hypothesis stipulating that there is no difference between the situations, groups, and outcomes is called. Right option is null hypothesis. Please take a note on important study questions. Thank you.